Hi, this is Janakareddy Dubbaka. Today I am going to add another series, that is paper explanation, and these are the questions collected from various institutes like Akash Allen, Physics Wala, Guru Krupa, New Light Test Series, and also Narayana and Chaitanya. And these are the questions useful for mains and NEET, very important one. And this series I am going to add already existing series, that is one day one NCERT concept. And this course is available in my app DJRPhysicsSir. Only ₹1 you have to pay, and this offer is only by the end of this month. But now for December 1st, I am going to charge some amount. Download immediately DJRPhysicsSir app from Google Play Store. In this video, we are going to discuss some problems from electric charges and fields. See here, electric dipole is placed in an electric field due to point source. Then, see here, for a point charge, intensity E is equal to kq by r square. See, for point charge, field is a non-uniform electric field. Therefore, in non-uniform electric fields, force does not equal to, net force does not equal to 0. And also, torque may or may not be 0. That depends on orientation of the dipole. Therefore, answer is force experienced by dipole will always be non-zero, while torque may or may not be 0. Next one, a point charge causes an electric flux of 4 into 10 cube Newton meter square coulomb to pass through the spherical Gaussian surface of radius 10 centimeter centered on the charge. If the radius of the sphere reduced to half, then flux that would pass through the sphere. Here, flux passing through closed Gaussian surface Q is equal to Q in by epsilon naught. This flux only depends on the charge inside the Gaussian surface, does not depend on size, shape of the Gaussian surface. Therefore, if you decrease the size or increase the size, flux does not changes, only depends on inside charge. Here inside charges does not changes. Therefore, flux remains same, that is 4 into 10 cube. Therefore, answer 3. Next one, the minimum possible electrostatic force between two point object placed at a separation is. Here, the minimum charge should be 1 electron charge, that is 1 electron charge is equal to 1.6 into 10 to the power of minus 19 coulombs. Therefore, force F is equal to 1 by 4 pi epsilon into E square by R square. Therefore, F is equal to 9 into 10 to the power of 9. This is 1.6 into 10 to the power of minus 19 whole square. Distance is given as 1 centimeter. 1 into 10 to the power of minus 2 whole square. See, after simplification, we get 2.3 into 10 to the power of minus 24 newtons. Next one, a force and a charge due to another charge. Here, when two charges are placed like this is Q1 and Q2. Force between them F is equal to 1 by 4 pi epsilon Q1 Q2 by R square. See, Q1 exert a charge force on Q2 and Q2 also exert a force on Q1 in same magnitude but opposite direction. This force does not depend on another charge placed in the surroundings. Therefore, it is independent of the presence of other charges. See here, a thin metallic spherical shell containing a charge Q on it. A point charge Q is placed at the center of the shell and a charge minus Q1 is placed outside it as shown in the figure. The force on the charge at the center is, see, for spherical shell, intensity inside is equal to 0. Therefore, force is equal to 0. But this minus charge does not influence any field inside the, or does not induce any field inside the spherical shell. Therefore, answer 0. See here, two concentric conducting thin spherical shells of radius r and 2r, charge q and 3q respectively. The magnitude of electric field at a point A and B at a distance x outside and inside from the surface of the outer sphere. See, this is the outer sphere. From that outer sphere surface, x is a distance of point A. Another one is x is a distance inside. At point B, you have to find out A. Therefore, for this point A outside, from the center, the total distance is 2r plus x. Now, total charge is q plus 3q. Therefore, at outside point, EA is equal to k into total charge is q plus 3q and distance is r plus x whole square. Now, inside point, here is a point B inside. It is a distance x from the outer surface. Therefore, the point B is now inside the outer sphere. Therefore, intensity is 0 and intensity only due to the inner sphere. Therefore, that intensity EB is equal to K into Q. Distance is here total distance is 2R and this is x. Therefore, remaining distance is 2R minus x whole square. But in the problem, these intensities are same. Therefore, EA is equal to EB. After simplification, you can get 2R by 3. Next one. Two insulating small spheres are rubbed against each other, are placed 3 centimeter apart. If they attract each other with a force of 0.256 newtons, then the number of electrons transferred from one sphere to another. When two spheres are rubbing each other, one body loses electron, gains positive charge, another body gains electrons get negatively charged. Here, if the, for example, one body loses electron n into E, at the same manner, second body also gains n into E electrons. Therefore, here force F is equal to 1 by 4 pi epsilon, here Ne whole square by distance square. But force is given as 0.256, that is 9 into 10 to the power of 9. This becomes n square into 1.6 into 10 to the power of minus 19 whole square. Here distance is 3 centimeter, that is 9 into 10 to the power of 4. Therefore, after simplification, we can get 1 into 10 to the power of 12. Next one, 3 charges Q, Q minus Q are placed at the vertices of equilateral triangle as shown in the figure. The force on the charge Q. See, due to this charge, it is a repulsive force, and due to this charge, it is an attractive force. Therefore, here this is a force, repulsive force F1, and this is the attractive force F2. Here angle is 120 degrees, and F1, F2 are both are same. That is 1 by 4 pi epsilon naught Q into Q square by side is given as A square. When two forces are equal forces acting an angle 120 degrees, net force also equal to one of them, that is equal to 1 by 4 pi epsilon Q square by A square. Okay. Next one. A halo charged conductor having charge density sigma has a tiny hole cut on its surface. Then electric field in the hole is. See here outside point, outside the sphere, intensity E is equal to sigma by epsilon naught. This is intensity due to hole plus intensity due to rest of the sphere is equal to sigma by epsilon naught. This is equation number 1. But inside the sphere, intensity E is equal to 0. That is E bar due to hole plus E bar due to rest of the sphere is equal to 0. Therefore, in magnitude, E bar whole is equal to E bar rest of the sphere. See from equation 1, therefore E bar whole, E bar rest also E bar whole, that is equal to sigma by epsilon naught. Therefore, E whole is equal to sigma by 2 epsilon naught. Answer 2 is correct. Next one. 6-point charges are kept at the vertices of a regular hexagon of side L and center O as shown in the figure. The electric field at center O is. See here, For this positive charge, intensity is away. Due to negative charge, intensity towards. And due to this positive charge away, due to negative charge towards. And here this is a charge 2q, distance is same, therefore field is double the charge E. Therefore this charge, positive charge away 2e, due to negative charge towards 2e. Therefore at this point O, the net field is equal to, this is here 2e plus 2e, that is 4e, plus and this is 2e. When you resolve in this direction, here angle 60, 2e cos 60, and this one also 2e cos 60. Therefore this becomes 2e cos 60 like that into 2. Therefore this becomes 4e plus 2e into cos 60 is 1 by 2 into 2 cancel. Therefore 4e plus 2e, that is 6e. Therefore net field at O is equal to 1 by 4 pi epsilon 6q by side is given as L square. Therefore E net is equal to 1 by 4 pi epsilon 6q by L square. Therefore option O, and that is in the direction OD. Next one. Two non-conducting spheres of radii R1 and R2 carrying uniform volume charge densities rho and minus rho respectively are placed such that the partially overlap as shown in the figure. At the point of overlapping region, the electric field vector is. For example, if you take point P in the overlap region, due to this sphere, this is a positive charge density, therefore intensity is away. And at this point, due to this sphere, negative charge, therefore towards. Therefore, in a non-conducting sphere, intensity is equal to rho by 3 epsilon naught into this distance rho r by 3 epsilon naught. Therefore, E bar is equal to, this becomes rho by 3 epsilon naught, here C1 P bar. Like that, rho by 3 epsilon naught, this is P C2 bar. Therefore, E bar is equal to rho by 3 epsilon naught constant, common, this becomes C1 P bar plus P C2 bar. Here we are adding this one, first vector, and this is second vector. Now joining the first tail of the first point to head of the second vector, this is a resultant of these two, that becomes C1 C2. Then E bar is equal to rho by 3 epsilon, this becomes C1 C2. Therefore option 2 is correct. Next one. Here electric field at x is equal to 10 centimeter is 50 I cap volt per meter, and at x is equal to minus 10 centimeter minus 50 I cap volt per centimeter. The magnitude of charge enclosed by the cube of side 20 centimeter having one edge x is equal to minus 10 centimeters in coulomb. See here, this side is at minus 10 centimeter and this one is at plus 10 centimeter. See here, at this point intensity is along x direction, positive x direction. Here intensity is along negative x direction. Therefore, here normal drawn to the surface in the direction of the field. Here normal drawn to this surface is in the direction of E2. Therefore, here total flux pi is equal to pi 1 plus pi 2. Therefore, flux pi is equal to, generally incoming flux is negative, outgoing flux is positive. But whereas here intensity also in this direction, therefore flux is positive. Therefore, this becomes E1 A1 plus E2 A2. See, flux pi is equal to EA cos theta. Therefore, here area vector, this is A1 bar. Here area vector A2 bar. Both are in same direction. Therefore, theta 0, cos 0, 1. And therefore, pi is equal to, here E1 is given as 50 into area is cube of side 20 centimeter. Therefore, this becomes 0.2 meters. Therefore, 0.2 into 0.2, 0.04. E2 also 50 into 0.04. Therefore, flux is equal to, this is 2 and this one is 2. Therefore, flux pi is equal to 4. But whereas flux is nothing but Q by epsilon naught, that is equal to 4. Therefore, Q is equal to 4 epsilon naught. Answer B correct. Next one. The point charge Q minus 3Q are placed at some distance apart. If the electric field at the location of minus 3Q due to Q is E bar, then the electric field at the location of Q due to minus 3Q is. See here, these are the two charges. One is Q, another one is minus 3Q. Minus 3Q. So here, if the electric field at the location of minus 3Q is E bar, at this location, this is a positive charge. Therefore, intensity due to positive charge is always away. Always away. And this electric field I am taking E is equal to K into charge Q. For example, this distance A square. And due to this negative charge in the location of Q, due to negative charge, intensity is towards. Therefore, this I am taking E dash. E dash and E both are in same direction. Therefore, E dash is equal to K into charge is 3Q by A square. Therefore, E dash is equal to KQ by A square is E. Therefore, this becomes 3E bar. In the same direction, therefore, plus. Next one. The circular ring of radius A has a linear charge density lambda is equal to lambda naught cos theta on its circumference. Then the total charge on the ring is. If you consider small element of dl, and this dl is nothing but here is d theta A, therefore dl is equal to A theta. If this is having charge dq, therefore dq is equal to lambda into dl, that is lambda into dl means A d theta. Therefore dq is equal to lambda is given as lambda naught A cos theta d theta. Therefore total charge is equal to integral dq. Therefore lambda naught A constant integral cos theta d theta 0 to 2 pi. Therefore q is equal to lambda naught A into integral cos theta d theta sin theta 0 to 2 pi. This becomes lambda naught A into sin 360 0 minus 0. Therefore q is equal to 0. Q is equal to 0. Next one. A charge Q is distributed on two different metallic spheres having radius r and 2r such that both spheres have equal charge density, then charge on the smaller sphere. See, equal charge density, sigma 1 is equal to sigma 2. Charge density means charge by area, that is Q1 by 4 pi r square, that is equal to Q2 by 4 pi, r means 2r whole square, 4r square. So 4 pi, r square cancel. Then Q1 by Q2 is equal to 1 by 4. Then I have to find out the charge on the smaller sphere means Q1. Therefore, Q1 is equal to Q1 ratio is 1, total ratio 4 plus 1, but total charge is given as Q. This becomes Q by 5. Therefore, answer 3. Next one. 4 charges, 2 coulombs, minus 3 coulombs, 6 coulombs and minus 5 coulombs respectively are placed at all the corners of a square as shown. Which of the following statement is true for the point of intersections of the diagonal? See here, potential is a scalar. If the sum of the charges is 0, potential is 0. See here, sum of the charges means here minus 3 coulombs, 2 coulombs and minus 5 coulombs, 6 coulombs. Therefore, this is 6, this is 2, 8 coulombs. and minus 8 coulomb. Therefore, charge 0, potential is 0. But intensity, see here, due to this negative charge, intensity is towards, and due to this charge, intensity towards negative charge, and this one is away, this one is away. Therefore, resultant intensity not be 0. Therefore, answer, electric field is not 0, but electric potential is 0. 7. Which of the following configuration of electric lines of force is not possible? See here, electric lines of force are never intersect. Here they are intersecting. Therefore, this one is not possible. And electric lines of force are not a closed curve. Therefore, this one also not possible. Therefore, answer 4, both 2 and 3. Next one. The variation of electric field vector from center of uniformly charged non-conducting sphere of radius r is correctly shown. For non-conducting sphere, E inside proportional to r, E outside proportional to 1 by r square. Therefore, intensity inside proportional to r, therefore graph is like this on both the sides, and outside it is inversely proportional. Therefore, option 2 is correct. Next, the angle between equipotential surface and electric lines of force. Electric lines of force and equipotential surface always perpendicular. Therefore, angle is 90 degrees. Next one. A neutral water molecule H2O in its vapor state has an electric dipole moment 6 into 10 to the power of minus 30 coulomb meter. If the molecule is placed in an electric field 4.5 into 10 to the power of 4 Newton coulomb, then the maximum torque that the field can exert. See here, torque tau is equal to Pe sin theta. When theta is equal to 90 degrees, torque is equal to maximum. That is, maximum torque is Pe. Therefore, tau max is equal to, here dipole moment is given as 6 into 10 to the power of minus 30. Intensity is given as 4.5 into 10 to the power of 4. This becomes tau max is equal to 27 into 10 to the power of minus 26 Newton meter. See, these are the problems I collected from various institutes test series papers. So very important for both mains and NEET students. Immediately download DJRPhysicsSir app, and in this series I am going to add one day one NCERT concept. It is absolutely free by the end of this month, and from next month onwards I am going to charge. Immediately download DJRPhysicsSir app from Google Play Store. Thank you.